Okay, I'm back again. Right, this is the third video, and if you remember from the last two videos, we had identified two areas of RAM, two RAM chips basically that were failing the memory test, and also on the memory map feature of the tester they were showing up as write-only RAM, which indicated that they were like getting the data changed when the tester was trying to write them, but it wasn't coming back with the right data, so there was obviously a problem there. I've now got a larger screen with the schematic up and obviously the tester up. In between the last video and starting this video, I've actually opted to take the two chips out and replace them anyway, but I did that after I did a couple of checks on the control signals, and I'll just indicate how I did that. I'll go through it again just to show you how I did it. This is a schematic for Zaxxon, and these are the two chips, the 2016 2K chips. And as you can see, each chip has a select line, a write enable and an output enable. You've got the address, you've got the data. So I wanted to check that the select lines were working, and I wanted to check the write and the output enables. To check the select lines, you have to write an address for that chip. So say for that one might be say 6800 hex, that might be 6000, which were the two addresses that we reckoned the two chips should be located at. So to check the select line, say, of one of the chips, what I did was I set the address to one of the chips, say 6000. And I set it in. Okay. Now, if I try and just check the select line, they would normally be high because they only go low when the chip is selected. So on the schematic you can see the top one, the pin 18. So if I go and check pin 18, I'll go to the front of the tester. You see nothing's actually showing up at the moment. If I go to pin 18, it actually shows high, which indicates that the chip is not being selected because they're active low, those two select lines. Take the probe off, put it back on, you can see high, and you can see me probing the chip there, as you can see. Okay. So what we'll do is we'll go back to there and we're going to set these select lines low. Now we've addressed it to 6000. Now unfortunately the test to get the select line to go low, you need to have the mem request line going low and the read or the write line going low at the same time. The tester will obviously bring these signals low, but it will put them back up high after it's finished doing a read or a write cycle. So to hold these signals low, because otherwise you won't be able to measure it because they'll just go low and go back up again. To hold them low, you have to actually force the signals low. So what we can do is we can type in a command force in, which basically will force the data bus of the tester to an input mode, but what that will do is it will hold it in the input mode, and it will also hold the mem request and the read lines low. So now it says the data bus is forced to input. So because we have an address on the address bus, and the data bus is now forced to an input, which means the mem request and the read lines are held low, one of those select lines should work. So if we go to the same one again, you can see now it actually goes low. It's the same pin I'm holding it on. Okay, so because it's going low, that chip was getting selected correctly. And if I go back to the schematic, I think it was possibly this one here I was checking, which is pin 18. So by doing that, I've actually verified that that chip there is obviously okay, and obviously all the associated circuitry for that is fine. I did exactly the same with the other chip, and it did the same. So I made sure before I changed these two chips that the select lines were actually changing state, because there's no point, you know, it might say the memory's faulty, you might go and just change them, but you know, if you've actually got a fault there, then they wouldn't be getting selected and you'd just be wasting your chips effectively. The other thing I wanted to do is check the write enable was actually changing state, and that is on pin 21, and because they're common together I only need to check one of them. So to get the write enable to go low, I have to do the same thing again. When you force it to an input, you can actually just put it back to normal just by doing one of these. As soon as you do that, that goes out and you're back to normal again. So if I did force out this time, it forces the data bus to an output state, which means the MemRequest line is still pulled low and held low, but also the write line will be held low this time because you're writing to the device. It's an output. So if we go to pin 21, we'll watch the front of the display. There's no display in this tester, by the way, but anyway, so go to that. 21 is now low. Take the probe off, you can see it goes. Just to show that actually does it, we'll go and do this again. That basically puts the tester back into its normal mode. And if I probe the same pin again, oops, I've got the wrong one, what's happened there? It's now high. So what I did there basically was to check that the write enable was changing state as well. I've checked the select lines, they're changing state. The output enable I did exactly the same way, but the output enable will only change state, will only go low when you're actually reading from the chip. When you're writing it, the output enable will stay high. So I checked all the control signals to the chip. The address and the data bus are commoned up with the rest of the system, like for example all the EPROMs. The fact I could read them all and everything else, and also it was doing other memory tests okay, which suggests to me that the data bus was all fine and the address bus was generally okay. So for that reason I then decided it's possibly the RAM chips that were faulty. So I took them out and I've changed them, which you can actually see down here. There's actually two sockets and I've put two 6116 chips in. The old chips are here, as you can see. I unfortunately destroyed them getting them out, but there was no damage to the board, which was a good thing. So I've got new chips in, and now if I do a memory map exactly the same way as before, remember it's going to be 1K steps for the memory map unless I change the default setting. You can see I go up, and then we got that RAM which was always there. It started at A000. We then went to video RAM, which was purple. It started at 8000 hex, and then as you can see here we've now got 4 blocks of 1K, which amounts to 4K, or those 2K chips, starting at 6000 going to 6FFFF, and it says these are read write and normal RAM, and that is what we didn't get the last time, so it seems to be fine. So the proof of the pudding now is to do a RAM test on those new chips. And we'll do 1000, which is a full 4K, and it's testing it at address 6000, as you can see, and we'll see what comes up this time. And it's passed the RAM test. So I've taken the 2 chips out, I've put 2 new chips in, done a memory map, done a RAM test on it, everything's passed. So it looks to me like those 2 memory chips were in fact faulty. We did verify all the control signals before we changed them. So the next stage would be to put the processor back in the board and then see what happens. So I'm going to stop this video and then I'm going to start another one with the processor back in.